Good morning, everybody. Welcome back to another episode of Math with Mr. Emond. We are starting a new unit today, a unit that hopefully you all find enjoyable and easy. This is a unit on absolute value equations and reciprocal functions. Let's get started. So let's take a look at what absolute values are. Whenever you see two vertical bars around a number or an expression, that's an absolute value. So something like this is an absolute value equation, okay? And these vertical bars are used to represent that absolute value of whatever is inside that, whatever number or expression is inside of there. So for a real number, any number, we'll represent that with the variable a. The absolute value is written as, you have the two vertical bars and then you put the a on the inside. So this reads the absolute value of a, and is always going to be a positive number. You will never get negative numbers with absolute value expressions. And that's because it represents the distance that a is from zero, and distance cannot be negative. It can have a direction, right? You can be 5 units to the left or 5 units to the right, but still 5 centimeters is 5 centimeters. It doesn't matter where you're going, right? So that's where absolute value functions are usually used. And let's move on. So let's link the ideas. The absolute value of a positive number is a positive number. So if I have the absolute value of 5, well, that's equal to 5, right? A positive number is going to yield a positive number. What if we have the absolute value of 0? Well, the absolute value of 0 is just 0. Zero's not positive or negative really, so we just write it with a positive sign. The absolute value of a negative number, this is going to have to become a positive number, right? So if I have the absolute value of -7, I know that's going to be 7. So how does this work out math-wise? Well, what we're actually doing is we're taking the negative of that number. So for example, the absolute value of -5 would be written as -5, and then these two negatives will cancel out, leaving you with the +5. So you can then, if this helps you remember, if you're looking at the absolute value of x or a, well, if x is positive or 0, it's just that number, so whatever it is. And if it's a negative number, then you're going to do the negative times that negative number to get a positive number. Or just remember that the absolute value of something is always going to be positive. Let's try a few. So we're going to determine the absolute value of a number. So the absolute value of 3, well, the absolute value of a positive number is a positive number, so it's just 3. That's it. Absolute value of -7, well, this would be now inside my expression here, my number is -7. And so what do I have to do? Make it positive by multiplying by a negative number. So this is going to be 7. So the absolute value of -7 is -7, making it positive. And I don't think I'm going to do this anymore, this negative. We're just going to kind of remember that the absolute value of a negative function, that's a positive one, right? It's always going to result in a positive number. Okay, it's your turn. Go ahead and pause the video now and work out these solutions and come back when you're done. For those of you on YouTube, welcome back. Let's go through the solutions. So the absolute value of 25, well, that's just 25. And the absolute value of -8, that's 8. Great. Let's do something just slightly more complicated. It's not all that complicated. We're going to write the real numbers in order from least to greatest. So we're going to have to deal with each of these things, and then we're going to order them after. So this first one, absolute value of -6.5 is going to be 6.5. Then we have 5. Then we have 4.75, positive yields a positive. -3.4, this is going to become positive, so this is going to be, let's convert it to a decimal, okay? This is going to be 2.4. Let's throw it in the calculator. Yeah, and it's going to become positive, right? So 2.4. And this is going to be 0.1. Again, it's going to become positive. This stays negative because there's no absolute value on it. And this one's going to be 2.5. So this is negative 2.5. Turn it positive, becomes 2.5. Now we can order them from least to greatest. Now we're going to try to match them up, right? So what's our smallest? It's this negative 3.4, which is just written the way it is, negative 3.4. So this one's gone. What's next smallest? This one, negative 0.01. So this one's gone. I'll cross these out too. Next we have 0.1, and this was originally the absolute value of negative 0.1. And I tend to try to make these absolute value signs bigger than my normal numbers because otherwise they just look like ones, right? So now this is gone. What's the next biggest? 2.4. So that was this one. The absolute value of negative 12 over 5. Okay. 2.5 is next, which is the absolute value of negative 2 and 1/2. So again, what we're trying to do is write them out in a common form so you can compare them. In this case, I chose just decimals. And now I'm reverting back to the way they were written before. And I'm writing them out in order. So 4.75, 5, and negative 6.5. And there's our answer. Okay. Good. Your turn. So give this a shot. Yours looks similar to mine with different numbers. Go ahead and pause the video and come back when you're done. Okay, for those of you on YouTube, welcome back. We have the solution for you. So first thing we did, just like the previous problem, is we converted them all into decimal places. Okay. Then we crossed them out as we went and ordered them from least to greatest. So here's your answer. Go ahead and check your work and let's move on. So here's the last thing we're kind of looking at today. We're actually going to be solving for expressions here. So this time what we're going to be doing is, doing our little conversions and then following our BEDMAS rules. So we're always going to do brackets before exponents, exponents before decimals, division, division before multiplication, addition, and then subtraction. Okay, so let's get started here. So this is going to be 4. The absolute value of 4 is 4. This negative sign doesn't get touched. And then the absolute value of negative 6 is 6. So then we have 4 minus 6, which is negative 2. Good. So we're doing each one, we're doing these first, right? And this is sometimes where students kind of get a little confused, is why can my answer be negative 2? And it's because all we're doing is changing the things inside the absolute value expressions to be positive, not the whole answer. That's going to depend on what functions are taking place. So let's try this one. Okay, we're going to have 5 minus, we're going to deal with this first, right? So 3 times the absolute value of 2 minus 5. We're doing what's inside. You can treat these like brackets. 2 minus 7 is going to be minus 5. So then we're going to have 5 minus 3 times the absolute value of negative 5. So 5 times 3, and then what's the absolute value of negative 5? It's 5. So this is going to become just 5. But remember, these are being multiplied. There's a multiply sign there. So now we're going to do this next. So 5 minus 15. And 5 minus 15 is equal to negative 10. So there's our answer. Okay. Again, following the rules of BEDMAS. So we're going to deal with what's inside these parentheses first. Now we go to these parentheses. So you're doing the brackets before anything else. So we have absolute value of negative 2. 5 minus 7 is negative 2. This is going to be squared plus 6. So we've dealt with this first. Now we need to move on to exponents. So we have the squared up here. So we're going to have negative 2 times negative 2 squared. Negative 2 squared is 4 plus 6. Now we do multiplication. So negative 2 times 4 is negative 8 plus 6. Now we are going to add these together. Negative 8 plus 6 is negative 2. And the absolute value of negative 2 is 2. So there is our answer for the last one. Now I hope you're starting to see, as long as you follow the rules of BEDMAS, you do them in the order of operations that math has laid out, you will always find the right answer. So again, we're going to have these brackets, right? And I know they're absolute value, they're how we write absolute values, but you treat them like brackets. So we're going to go inside here first. So this is the first thing we do before we even look at this. Now we are going to deal with the multiplication piece first. So we're going to have negative 3 times the absolute value of 2, and then minus 4 times 3, which is 12. Then you're going to subtract these. So negative 3 times the absolute value of 2 minus 12, which is negative 10. Now we can deal with this bracket here. So absolute value of negative 10 is 10. And now we multiply. Negative 3 times 10 is negative 30. So again, we're just following the order of operations, and as long as we do that, we're going to be golden, in good shape. Okay, your turn. Give these a shot. For those of you on YouTube, pause the video now and come back when you're done. All right, everybody, welcome back. We have the solutions for you. Let's take a look. So the absolute value of 5 minus 6 is negative 1. Absolute value of negative 1. Absolute value of negative 1 is 1. Here we have the absolute value of 2 is 2. And then the absolute value of 3 times negative 4 is negative 12. Now the absolute value of negative 12 is 12. So then you have 2 minus 12. And 2 minus 12 is negative 10. On this one, we're going to deal with the exponents first. So negative 2 squared is 4. And then we just wrote everything out. Then we're doing multiplication next. So 5 times 4 is 20. And 7 times negative 3 is negative 21. And we wrote everything out. Now 20 plus negative 21 is negative 1. Minus 15 is negative 16. So we have the absolute value of negative 16 here. I'm just going to clean this up a bit. And the absolute value of negative 16 is 16. Hopefully you got those all correct. Let's end the class by doing a word example for you. This is, again, with absolute value functions, you're not going to find ones that are incredibly difficult. So on the stock market, individual stock and bond values, they fluctuate a great deal, especially when the markets are volatile, like right now. A particular stock in the Toronto Stock Exchange, TSX, opened the month at $13.55 per share, then it dropped to $12.70, then it increased to $14.05, and closed at the end of the month at $13.85. Determine the total change in the value of this stock. So how much change did it go throughout the month? Okay, well, let's look at the first change. So we went from $13.55, and then it dropped to $12.70. So what I did here is I did the absolute value of the difference, because the difference here is going to be the change, right? How much it changed. And then what was the next one? We went from $12.70 and then to $14.05. So again, this looks like it's going to become a negative number, right? We're looking for the difference between the two, but we're going to turn it positive with the absolute value signs. So that's fine. We're just looking at the difference between the two. And then the last one is we started at 1405 and we finished the month at 1385. And so again here, it's going to be negative, but it's going to become positive. So I'm just going to do this little piece in my calculator here. So we have 1355 minus 1270, which is 85 cents. So we have the absolute value of 0.85. Plus, let's do the next one here. 1270 minus 1405, which is going to be negative 1.35. And let's do the last one. 14.05 minus 13.85, and that's going to be 0.2. Okay. Now we can turn these positive. So we have 0.85 plus 1.35 plus 0.2, and this is going to be our total change. So we have 0.85 plus 1.35 plus 0.2 equals 2.4. So our net change was $2.40. And that's going to be it for today. Thank you for watching. See you next time. Thanks for watching, everybody. You can like, follow, and subscribe to my social medias to get notifications as soon as new content is uploaded. In the top corner here, you will find the playlist that this video is in. Watch the unit from beginning to end. And over here, you will find the next video in this unit. Keep learning, everybody. Take care.